Yes, so the first column is the timestamp. So if you see, this is a timestamp in seconds. So typically the messages have periodicity of 10 millisecond, 20, 50 millisecond, or even 100 millisecond. So these are typical periods of messages which you could see on a regular canvas. Okay, so yeah, so you see, but that is the periodicity of one message. And then typically there are around 20, 30, even up to 50 message types that you could see on each bus, which means that there are 50 different subsystems which actually are transmitting those messages. The brake might be transmitting one message, or the brake might be transmitting 3-4 messages. One about the pedal position, the brake pedal position, one about whether the brake is in good health, and similarly engine might be sending 5 messages, whether engine oil is working fine, whether there is what is the speed of the engine, anything. So there might be 4 or 5 messages which will be sent by the engine. Similarly, steering wheel might be sending a few messages. So every component might be sending one or more messages. So in total there might be 30-40 messages. I don't know how many messages are there in this data set. You will have to figure that out. Okay, so so each message may have some periodicity, and then because you are seeing all these different messages which may have different IDs. Okay, so let's see this message 316. Okay, so this might come periodically. So of course you will have to parse it in a program. You can easily write a program and parse these things. You do not need to do what I am doing currently. So I will try to see when. So the column number 1 refers to this 316 message ID, and I am trying to do find all. So there are many such messages. Okay, so yeah, so B1 had 316, then B17 has 316. Okay, so if I go to B1, the time is 38942, B17 is 39956. So it seems the periodicity is around 100 millisecond. So this is just some calculation. You will have to, of course, look into all these messages and find the average, the mean value, in order to find what will be the periodicity. I'm just looking at 2 messages and guessing what could be its periodicity. So it seems that it might have a periodicity of 100 millisecond. Okay, so I know that there might, so first I will need to know how many messages are there. So for that I could probably write, at least in Excel I could probably find it by this unique key. Okay, so B. Okay, so I have some around probably 26 unique messages, or 27 unique messages. 0, I don't know what this 0 is, but yeah, it seems that we have around 26 unique messages. Okay, so there are 26 messages here. Then the periodicity of 316 is something. Similarly, you will have to figure out what is the periodicity of all these messages. Okay, so are you with me until this point? What is happening here? So we are doing some sort of reverse engineering here. So we are looking at the traffic, we have logged the traffic, and now what we are doing some reverse engineering. So any questions here?
Sir?
Yes.
Sir, what if the settings that are mentioned in the research paper that you have shared, means around 117 entries out of 120 process IDs, we are having frequencies greater than 50 Hertz. So is it the case with that data set as well?
So can you please repeat?
sir, you shared the research paper. In that paper, there are around 120 process IDs, different process IDs. So out of them, 117 process IDs are having frequency more than 50 hertz. So is it the case with this data set as well?
Yes, so see, they have used another data set. You don't need to worry about what data set they have used. I will talk about how you could use that paper. So let me just also talk about it. I want you to finish this assignment in 2-3 days, and therefore I will help you with that as well. So you do not need to look into the data set that is used by that paper. You have to worry about only this data set. So I do not know what are the periodicity of these different messages which are present in this data set, but typically messages have a periodicity of a minimum of 10 millisecond. A maximum could be, so what I have seen is 5 seconds. I have not seen anything beyond 5 seconds. Yeah, so it could be any value in between those numbers, expected value, but it might be different as well.
Sir?
Yes, go ahead, Arun.
Sir, in this data set, there are malicious messages also. So when there are malicious messages, the mean value will change, and when there are no malicious messages, mean value will be different, sir.
Yes, so I want you to figure at least that part.
Yes, sir.
Yes, yeah, yes, that is correct. Okay, okay, so remember, so this is what I actually did the first part. So how many different message identifiers are there? So you know what are there. Then you will have to use only the benign messages to find out their periodicity. So as Arun was mentioning, if you include the malicious messages, you will get wrong values. Okay. So then you figure out what is the periodicity of it. Okay. And then it is now what we have to do. So let's say this is which data set? So DOS data set. Okay. Okay. So possibly the malicious message has ID 0. So let me just try to see. Let me probably filter the messages. Okay. Yes. So the ID for the malicious message is 0, and all malicious messages are of length 8 bytes, and the content is all 0. Okay, so this is DOS attack. So okay, that sounds good. So what you need to do is first see that so you have to detect the denial of service attack, which means that some service is some availability property is being violated. Now, in this case, what we are looking at is only the inter-message arrival time. Okay, so now let me go to remove this filter. Okay, so what you have to do is clear the filter. Okay, so what you have to do is you have to find out so for each of these message types, what is the periodicity of the benign messages. Now, when these denial of service messages come, they will change that periodicity by a small amount. So you will see a small variation in the periodicity of some of the messages. So you will not see the change in the periodicity of a lot of messages, but you will find out that there are some messages whose periodicity has been altered. And there you will have to detect that, okay, so if there was no adversary, when there were no messages with the level T, in that network traffic, what was the periodicity of a particular message, and when these malicious messages started coming, then what was the inter-message arrival time. So when I'm talking about inter-message arrival time, I'm talking about the time two messages with the same ID come on the bus. So two messages with the same ID are recorded from the bus. So message timing is not the timing between two consecutive messages. It is two messages with the same message ID, which means this row 1 and this row 70. So inter-message time here is whatever is the time corresponding to this minus whatever is the time corresponding to this. Okay, so that is the inter-message time, and you have to look into this timing and for different messages and figure out whether there is an attack or not. Okay, now let me talk about what we could do. So modeling inter-signal arrival times for accurate detection of CAN bus injection attacks. So you can go through some of these, some of the information that is given in the in this paper, and you could do very similar thing. You could probably draw some histogram. That is also fine. I'm sure that even the histogram will indicate some anomaly that could be identified. So notice that I have selected a paper which does not have a lot of details. It is just a very short paper, only very small in terms of a research paper. So I did not want you to read a lot of things. I just wanted to highlight that these inter-signal arrival times could be utilized for detecting these attacks. And yeah, this paper will also help you get this broader idea about these type of attacks. So I do not need to write all of that in the assignment. So therefore I selected this paper. Okay, so that part is also clear, that you have to look into what inter-message time. So it is not the consecutive message, it is the messages with the same ID. Okay, and once you have these inter-message times, just probably you can start with a histogram and see if there are variations between the period in which there were no malicious messages and the period when the malicious messages start coming. So let's see. So this 1477 is the row number where these first malicious messages have started coming. So in this period you should be able, and then I do not know when the last would be, but during that period you will see changes in the periodicity of some of those messages. And okay, so then comes the machine learning part. Okay, so at least are things clear to this point, that what is it that we are looking for? What does this inter-message time or inter refer to?
If we simply say that when the message ID is 0, it is a malicious message, will that not be a correct form of identification?
You can.
Without any.
You can, but I do not. Yes, of course, that is the easiest thing. But so this is probably a dumb attacker, which is actually launching this denial of service attack by just using all zeros. There could be other IDs, intelligently selected IDs that the attacker could have used in order to do the same thing. And therefore, just the ID based detection is probably not possible. Of course, in the message impersonation attack, detection of the message impersonation attack, you will actually do some sort of ID based detection, and they're different. So very similar strategy. So what I want you to do is follow the same strategy and then modify that strategy a little bit to detect the denial of service attack and to detect the message impersonation attack. So yeah, so that is a good observation, Ramita, but yeah, please don't use that technique.
Sir, is there any use of these columns from C to A
No, there is
payload?
no.
Okay.
Yeah, there is no use for those messages. You can safely ignore that. So yeah, so there might be some use. So when you are parsing, it would be useful. So see this message, which has the identity 5F0. So the length of the message is only 2. So then the label, whether it is benign message or malicious message, that comes in column F. So in that sense, you need to actually read at least the column C and then figure out whether it is a malicious message or a benign message. Read that label. So while parsing, it is important to probably read the column C. Yeah, but the data is not important. Yeah, probably at some point, no, probably not in this course, but of course, data could also be utilized to design intrusion detection systems, but in this assignment, you are not doing that.
Sir, in this 1433 row, whatever the classification is, the classification that is R. So the format is not correct in this case.
What?
In 1433rd row, the classification means we are classifying it in R and T. So here the R is not in the proper column. It should be in the last column. So we will have to at least drop such rows.
No. You have to use that data. It's just a way of parsing. So in this Excel file, it is here, but who is telling you to just use this Excel file? You could create your own data structure, store all this information in that data structure, and then use it. So you do not need to use this Excel file to do the analysis. Yeah, so if I use this Excel file and start drawing figures and histogram here, then of course I will have to drop these messages. But when you will be writing a program or a code, please create your own data structure, store all of this time information, ID information, and then the label. So these are the only 3 important things: time, ID, and label. But when you are extracting that information from this Excel sheet, the parsing part, there you will use this column C. Sorry. Yes, so there you will use this column C. You do not need to drop those. You do not need to drop those rows. It is not a difficult code to actually use such parsing.
Okay, sir. And what this first column represents here?
Time.
Okay.
Are there any anomalies expected in the data itself that we need to figure out?
Yes, so there will be anomalies in the data as well, but in this assignment, I'm not asking you to do that. So a real world IDS will look into all different features, and inter-message time is just one feature. There could be probably dozens of features that a real world IDS will look to detect an attack, and database features would also be included in them. So in this assignment, I'm just asking you to look into inter-message time. You can probably look into more features. So features would be the mean value of the the intermessage time. So periodicity, in other words, we could say that mean value of the intermessage time. So that will be one feature. Now you could use just that feature, train a model, and then, so I will talk about what to do next, but you could just use one feature or you could use multiple features. But in this case, I do not expect you to look into the data. Of course, if you want, you can extract more features from intermessage time information. So more features would be, for instance, mean, standard deviation, whatever other feature that you. So in the time domain, you might do an FFT, look at something in the frequency domain. So all of that is fine. So you can play with that information, the intermessage time information, and try to extract as many features as you want, but you do not need to look into the data.
We can safely assume that there are no null values or all the labels are there. There are no missing labels like that, right?
There should not be. I have not looked into this data carefully.
Or maybe some data type mismatches. I hope all those issues
So
are not.
try this thing, and if you figure out that there is something wrong with the data, then just drop a message on Piazza, and we will try to see. Okay. So okay. Okay. So now that it is clear that okay. So in fact, it would be nice to bring out that figure. So the way I am actually talking about these things, it also follows that figure that I'm discussing in the detection system. Where is that figure? Okay, oh yes, this figure. So we are looking into this network intrusion detection. So we have this attack network traffic. So we did some packet sniffing of the data. We have some dump, not the TCP dump, but something. And what we have to do is we have to do some pre-processing to extract these features. So the packet headers will probably contain this timing information and stuff, and all of that has been done. So pre-processing, what you will do, you will look into this data, you will figure out what are the IDs, what is the periodicity, all of that comes as part of the pre-processing. Okay, so now we are in that area where you have to utilize some machine learning model. Okay, so now, as I said that you have to look into this inter signal arrival time and then extract some features. So probably reading this paper will actually give you some indication of what is it that I'm asking. So if you have never trained a machine learning model, it is going to be difficult. So I would say that do your best, even if you have never done a machine learning course. Just try to do your best. So I would say that if you just utilize this nearest neighbors, nearest neighbors, this would be good enough. So okay, so this is the figure. Okay, so what happens is that if you plot features, so let's say that there are two features that you are plotting. One is the mean value of the intermessage time, and one is the standard value, standard deviation of the intermessage time. So then you will see that there will be two groups. So when you are actually looking into some benign samples and some data sample, benign messages and the traffic during the when the attack was on. So you will see that there will be two groups. Okay, so there will be one group of messages. So these dots, each of those dots present one message type. So you will see that when there was no attack, the values were around this part, the intermessage time. So intermessage time for will be around, will make a cluster, and when there will be an attack, the intermessage time will form another cluster. And you can say that, okay, so now I see, so I have plotted it. If you just want to use one feature, you will have a linear plot, and you will see that some dots will be on one corner, some dots will be on the other corner, and then you will be able to visually say that, okay, it seems that these are two clusters uh, which can indicate whether there is an attack or not, or no attack. Then what you need to do is you need to select how many neighbors could be there. So in this case, you can go ahead and easily select 2. So this number could be just 2, because there will be a scenario of benign intermessage times. There will be a scenario of corrupted message times. Okay, so you can choose this number k to be 2, and then you will. So I don't want to go through all of that. So okay, so the code is also there. Okay, so I would leave at that point, but yes, so once you figure out that visually, that you plot those dots and you can figure out visually that there are only 2 clusters, then you just write this a small code and import these libraries, write this a small code, and you will be done. Okay, so that is about machine learning, but I also want to talk a little bit about training. But
Sir, can we use MLP classifier from sklearn library?
you can use anything. I just wanted to say that nearest neighbors is the simplest of algorithms. You can use even this algorithm. You can of course use any other algorithm, and the complex algorithm you use, you get probably higher accuracy. Okay, but remember, the grading will not happen on getting higher accuracy. It is about it will be combination of everything. You get higher accuracy, you have good discussion in the report, and you have good presentation of the results that you have obtained. All of that will matter. Okay, so
Sir,
yes, yes.
sir, in this k nearest neighbor, there will be 26 clusters, no? Because there are 26 different types of messages.
This is just the way you can interpret it. So please feel free to interpret it like that. So what I was saying is that for each message, if you plot, you will see 2 clusters. And if there are 26 messages, so you could detect the anomaly per message wise, or you could accumulate all different messages and then detect an anomaly. So it depends on the design. Feel free to use any design.
Right.
Okay, so I have, yes, what I have suggested is the simplest design, that you plot the intermessage time for one message. You will see 2 clusters, and then you can use that for detecting the intrusion. So that is probably the simplest design, but of course that design will not give very high accuracy. For higher accuracy, you have to be a little bit more innovative.
So any
Okay.
particular
Yes.
recommendation for the any recommendation for the libraries we can use?
Yes. So as I said, so these things are very, very easy, and it can be done in just few lines of code. If you see, if you just go ahead with k nearest neighbor, these are the libraries that you will have to use. Um, it should not. So in terms of understanding what to do, it will take some time. But once you understand what to do, writing the code will take probably lesser time. But since you will be writing this code for the first time, it might still take some time. But it will be a good learning experience in any case. Okay. As I have already mentioned, actual payload data will not be utilized to detect any anomalies. So we are not interested in that. We are only interested in inter-message arrival time. Okay. And so this is one data set. So DOS, and for the impersonation attack data set, so gear_attack or gear_ data set, you will try to figure out what are the things that I should notice in order to detect the attack. There will be similar things. You are still looking at that inter-message arrival time. Okay, and then divide the data set into appropriate training and validation set. If you have done some ML, then you know you can use different ways. If you have not, then let me just say that what you can do is you can so depending on your understanding, you can divide the whole data set into two parts, one for training your model and one for detecting the accuracy of your model. Okay, so any division will be accepted if you do not have any background, but things like cross validation, dividing data into 10 parts, then doing it using one part for validation, remaining 9 for training. So all these techniques would also be appreciated if you use all those techniques. Okay, and if you do not have any background in ML, it is fine to use any technique.
Sir, in testing part, do we assume that there is only one sample? I mean, or we are given with a some let's suppose 100 samples, and then we start predicting for 100 first, 100 second, 100 third, and so on and so forth.
No, so you so what we are doing is we are thinking about offline training and then offline detection of attack. Okay, so no runtime detection or runtime training happening here. So what you will do is you will see this data, just divide this data into some parts, and of course the training data should have some malicious samples, otherwise things won't work. There you train the model, and you have only two classes, malicious and benign. You train the model with them, and then remaining data, for the remaining data you look into the inter-message time, try to see whether you should label it as malicious or benign, and then you just compare it with the actual label and then calculate the accuracy. So so did I answer your question, or
but sir, since this is a time series data, we have to split it. Hello?
Yes, so in the real world things happen differently, but since you already have this data offline, I would just suggest to do it in a simple way. So network intrusion detection is a difficult problem. Okay, so if Subrat was here, he would tell you. No, he is not. So he is working on network intrusion detection system. So it is a difficult task. There are many things involved there. I'm not asking you to think about the complexities of network intrusion detection system. And one task is that this is the time series data. So that is very, very different than doing classification of images and stuff. But what I'm saying is that consider this data as offline data. Think of it as just data samples on which you have to work. Don't think about it as a time series data. Think about it as that once you have this inter-message time, you have a data sample. So that inter-message time is a data sample for you.
Great, sir. Thank you, sir.
Okay, so I have left the last part ambiguous. So I want you to think about at least that last part, and hopefully at the end of this assignment you will learn some new things. Okay. Okay, good. Okay. Any other question related to the assignment?
Sir, can we use tools like Vika or?
Please feel free to do that.
Okay.
So, so how has this demo for assignment 3 been for you? I mean, so for the assignment 4, you will also have to do some demos, but let's schedule it after the major examinations. Yeah, because we don't have any time left. Yeah, so you can feel free to use Veka, but remember that you will have to demonstrate your results.
Sir, what is expected in the report other than the running of the program and all?
So just some screenshots. The most important values are the detection accuracy. So what is the so out of let's say 100 samples that you are detecting, are you predicting the correct label using the trained ML model or not? So you will first train a model to predict whether a data sample is malicious or benign, and then you will compare that with the actual label that is given in this Excel sheet, and if they match, then you have correctly detected it. If they do not match, then you have made a mistake. So you have to report how many times you make a mistake, how many times you have correctly detected it. So in percent, so for how many percent times. So typically, if you use a decent algorithm, your accuracy should be above 80%, which means 80% times you will be making correct decisions. I think I talked about, yeah, I talked about detection rate, false alarms, I mean false positives, false negatives. So what you need to do is you need to report these values. So true positive, true negative, false positive, false negative.
And sir, what is the key difference in impersonation attack and DOS attack? I mean, what we should look for?
So these are two different attacks, and the intrusion detection system can use very similar things to detect these two attacks. Okay, so it can use this inter-message timing to detect both attacks, but there will be slight change in the strategy. So you have to think about what could be the slight change in that strategy. Okay, so the idea will be very similar. You will look into inter-message time. You will see which part are benign messages. So you will you will learn from that part what is the benign behavior, and then you will look into the part where there are benign as well as corrupted or malicious messages, and there you will try to see what is it, what messages have these changed inter-message times. So for what messages are being impacted due to this attack, this particular attack, and then you figure out how to design that idea, which means that what to do to detect that. Okay, so these are two different data sets, different attacks. You will have to just do a slight variation in the strategy, and probably the same code that you will write will work, but yeah, there might be small changes that you may need to make.
So in impersonation attack, payload is not very. I mean, we should not bother about it. Payload.
Yes. So in both the attacks, you should not worry about the payload.
Sir, as we are calculating inter times between two events, between two message IDs. So when we test, basically we have to uh, basically uh, check whether both of them belongs to benign category or malicious category, or is it possible that first was benign but it came after some duration which is malicious, so second was malicious. So in that case, how basically we attribute them, both are benign or second is malicious or both are malicious?
Very nice, good question. So think about the answer. So that is the last part. So you have to just so at least make that logic. I already told you what to do, how to reach at that level. Now you have to. So that is where some discussion is needed. Otherwise, you could just write a code and it will work. So that is where everyone's answer would be different, and that is why these open-ended questions have some merit. Otherwise, there is no merit in having any open-ended question if the answers could not be different. But I guess you have reached the final leg of the solution, so hopefully you will figure out. Okay, any last question? Okay. Okay, so then does any of you have any question related to the project? I hope that you have already worked on your project and you already have some results. Uh, and then I hope that you just need to write a report.
Actually, both these things are now there. This assignment and this project report, both these things are kind of overlapping.
Yes, so I have tried to leave one day for just the report writing, and then you will have 2 days for presentation. So you can probably think about do some sort of probably, and note that I have also allowed late submissions for this assignment. So you'll have to do, you have to figure out a strategy. And remember, you also had these free late days that you could have utilized. I don't know how many of you have already utilized those free days. So remember the policy that I announced that you use 7 free. Those there will be no late penalty for those 7 days. So if you have not utilized those 7, feel free to utilize them.
Right.
So the presentation will be online.
Yes, yes, presentation will be online. Okay. Yeah, so typically the end part of the semester is always very busy. So it is all right to be a little busy at the end of the semester. Okay.
Sir,
Yes.
one question, please. Sir, for this
Yes.
assignment, can we record a 5-minute video for the demonstration? And if it doesn't satisfy the evaluator, then we can go for the actual demonstration. Can we do such thing like that?
Yeah, that can also be done. But yeah, I guess recording a 5-minute video is something which is not easy for everyone. I mean, that continuous 5 minute of. So the thing is that when so the questions that we want to ask, I will have to specify all of that, so that your demonstration, what demo that you are doing, should have at least all those things. It is not very straightforward. Feel free to create a video, but we will see what to do with it for the demo after the major exam. So the major exam is on April 6th. So we will think about what to do with this demonstration after April 6th. Probably
Okay,
after
sir.
April or so.
Okay, sir.
Sir, will lab 3 grades be released before major exam?
Sorry.
Lab 3 marks will be released before the major exam.
So for this assignment, we may not be able to release the marks before the major. But yeah, the assignment third grades will be released before the major. And then you will have the projects grades also released before the major. So what will be left is the major exam marks and assignment 4 marks.
Sir, there is no placeholder in Gradescope for the presentation. What is the deadline for that?
I had just used a placeholder for it. I don't remember. For the presentation, April 1st, 10 a.m. Okay, so April 1st is the day when we will have the presentations. So I want you to submit your presentation in the morning of April 1st, so that we could use the whole day for on April 1st to do the presentations. We will see based on the number of reports that will be submitted. I will figure out how much time it will take for all the presentations to happen, and then I will publish the schedule on March 31st, share the schedule on March 31st, and then on April 1st we will have presentations.
Roughly how many minutes will be allocated for each presentation?
So I had shared that information.
Yeah,
I
it
think
was 10 minutes.
it's
It was 10 minutes
10
earlier,
minutes.
so it will be same. So it will be same 10 minutes only.
No. For midterm presentation, it was a different number. For
No, it
final
was
presentation,
5 for midterm presentation, 5 minutes, and 10 minutes for final term. So it will
yes,
remain 10 minutes. No?
yes, it will remain 10 minutes.
Right.
And this is what you follow for your presentation. I mean, you could do, of course, go beyond what is written here, but at least these things should be there in your final presentation.
Sir, one more thing, like whatever we have presented in midterm, like suppose background or theoretical part, we don't need to repeat it now, right?
No, so you do not need to repeat a lot of things, probably most of the things in background and related work, but you need to talk it in a manner so that at least you motivate the problems sufficiently enough. So I would suggest that you definitely talk about the introduction, so that 1 or 2 slides, and then you go down to the problem statement. You can probably skip the related work section, but yeah, you do spend some time. So this is a presentation on its own. So you can skip some of the things, but do not skip a lot of things that you have already presented, because otherwise the flow of the presentation will break. Okay, so yeah, try to give lesser time on introduction, background, and problem statement, and then give more time on the evaluation and the proposed solution. Talk about them very briefly. Yeah, so you can talk about these three parts very briefly, but it would be good to talk about them.
Sir, has it been finalized the timings of the presentation, maybe 1 to 3 years, something like that?
What?
The timings of the presentation, has it been finalized?
No, so that is what I said, that uh, on March 30th, I will see how many reports have been submitted. I have not been able to, so many of the students have already audited the course. So they will probably not submit the report. So based on the number of reports that I see on March 30th, I will decide the schedule on March 31st, and then I will share it on March 31st, and we will see what to do on April 1st. So April 1st is a Friday. So if it could be done in 2 hours or 4 hours or 5 hours, we will see. It depends on the number of submissions. Okay. Okay. Any final comments? Okay. So work on the assignment over this weekend. I mean, half of the weekend is already over, but please work on it, and then please post your queries on Piazza. We will try to reply to those queries as soon as possible. Okay. Okay. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.